The National Electrical Code Section 230.6 Exception 2 addresses the allowable length of service entrance cable (SEC) inside a building before it needs to terminate at a disconnector panel. Generally, the service entrance cable can extend into the building for a maximum of 10 feet beyond the point of entrance without needing to be terminated to a disconnector panel. However, there's an exception. If the service entrance cable is used to supply only a single appliance that is located within 6 feet of the point of entrance, then the service entrance cable doesn't necessarily need to be terminated to a disconnect. It is critical to understand that local jurisdictions may have more stringent requirements than the NEC. For example, some local codes might require a disconnect to be installed within 6 feet of the point of entry of the service entrance cable. Therefore, it's always best practice to check with a local code authority to determine if any additional or more restrictive requirements exist in the specific area. The reason for these requirements is twofold. Firstly, to provide a convenient and readily accessible point to disconnect the entire building from the power source. This is crucial in emergency situations such as electrical fires or for routine maintenance and repairs, and secondly, to protect the building and its occupants from electrical hazards that might arise if a fault occurs within the service entrance cable itself. Limiting the length of unprotected cable inside the building reduces the potential for damage and injury in the event of a short circuit or other electrical malfunction. The National Electrical Code (NEC) establishes a baseline for electrical safety across the United States. However, it's important to remember that the NEC is not law unless it's adopted and enforced by a local jurisdiction. This means that cities, counties, and states can amend or add to the NEC requirements to address specific local conditions or concerns. Some common local amendments might include stricter rules on wiring methods, grounding, or overcurrent protection. They might also address specific environmental conditions such as high humidity, coastal areas, or regions prone to earthquakes. Always consult with a local electrical inspector or building department to understand the specific requirements in the area. This is the only way to ensure compliance with all applicable codes and regulations. When installing service entrance cable, several factors should be considered to ensure a safe and compliant installation. Firstly, the type and size of the cable must be appropriate for the intended load and voltage. This is determined by calculating the total amperage of all the devices and appliances that will be powered by the service and selecting a cable with an ampacity rating that meets or exceeds the value. Secondly, the cable must be installed in accordance with the NEC and local codes. This includes using approved wiring methods such as conduit or cable trays, and properly supporting and securing the cable along its run. Thirdly, the cable must be protected from physical damage. This might involve installing it in a location where it's less likely to be struck by vehicles or equipment, or using a protective covering such as conduit to shield it from impacts. Grounding is another critical aspect of electrical safety. The NEC requires all electrical systems to be properly grounded to provide a low impedance path for fault currents to return to the source. This helps to prevent electrical shock and minimize the risk of fire. The grounding system typically consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the service equipment and the building's grounding system. Overcurrent protection is also essential for preventing damage to electrical equipment and wiring. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the flow of current if it exceeds a safe level. This can help to prevent overheating, fires, and other electrical hazards. The size and type of overcurrent protection devices must be carefully selected to match the ampacity of the wiring and the requirements of the equipment being protected. The service disconnect is a critical component of the electrical system. It provides a means to quickly and easily disconnect the entire building from the power source in case of an emergency or for maintenance. The service disconnect must be readily accessible and clearly marked. It should also be located in a convenient location, such as near the point of entry of the service entrance cable. Electrical inspections are an important part of the building process. Electrical inspectors are trained to identify potential hazards and ensure that electrical installations comply with all applicable codes and regulations. A thorough electrical inspection can help to prevent costly mistakes and ensure the safety of the building and its occupants. In addition to the NEC and local codes, there may be other standards and regulations that apply to electrical installations. For example, the National Fire Protection Association (NFPA) publishes a wide range of standards related to fire safety and electrical safety. These standards are often referenced in building codes and regulations. It's important to stay up to date on the latest codes, standards, and regulations. The electrical industry is constantly evolving, with new technologies and best practices emerging all the time. Continuing education and professional development can help electricians and other electrical professionals stay informed and provide the highest quality of service. When working with electricity, always take precautions to protect oneself from electrical shock. Wear appropriate personal protective equipment (PPE), such as insulated gloves and safety glasses. Never work on live electrical circuits unless absolutely necessary, and always follow proper lockout/tagout procedures to ensure that the circuit is de-energized and cannot be accidentally re-energized. Consider a scenario where a single-family dwelling has its electrical service entering the building at one corner. The electrical panel is located approximately 12 feet away along an interior wall. According to the general rule of NEC section 230.6 exception 2, the service entrance cable cannot extend more than 10 feet into the building without terminating at a disconnect or the panel itself. In this case, the cable would need to be terminated at a disconnect within 10 feet of the entry point. This means a disconnect would need to be installed somewhere between the entry point and the panel. Now consider a different scenario. The service entrance cable enters a building and immediately feeds a dedicated electric water heater located only 4 feet away from the entry point. According to the exception in NEC section 230.6 exception 2, since the service entrance cable is only supplying a single appliance, the water heater, and the appliance is located within 6 feet of the entry point, the service entrance cable does not need to terminate at a disconnect before reaching the water heater. However, it's essential to verify that this installation meets all other applicable requirements of the NEC and local codes, such as proper grounding and overcurrent protection for the water heater circuit. It is important to clarify the term point of entrance. The point of entrance is generally considered to be the location where the service entrance cable passes through the exterior wall of the building. This could be through a hole in the wall, a conduit sleeve, or other approved method. The 10-foot measurement begins at this point. When calculating the distance the service entrance cable extends into the building, it's important to measure the actual length of the cable run, not just the straight line distance between the entry point and the termination point. If the cable is routed around obstacles or takes a winding path, the actual length of the cable could be significantly longer than the straight line distance. It is important to also address the type of service entrance cable. The NEC recognizes several types of service entrance cable, including Type SE, Type Use, and others. The specific type of cable that is permitted for use in a particular application will depend on the voltage, current, and environmental conditions. For example, Type Use cable is often used for underground service entrances because it is suitable for direct burial in the earth. The NEC contains detailed requirements for the installation of each type of service entrance cable. These requirements cover topics such as conductor size, insulation type, ampacity ratings, and methods of support. It's important to carefully review and follow these requirements to ensure a safe and compliant installation. One common question that arises is whether the 10-foot rule applies to underground service laterals. A service lateral is an underground cable that runs from the utility company's transformer to the building. The NEC does not specifically address the length of service laterals inside the building. However, most jurisdictions interpret the 10-foot rule to apply to service laterals in the same way that it applies to service entrance cables. Therefore, it's generally recommended to terminate the service lateral at a disconnect or panel within 10 feet of the point of entry into the building. Another important consideration is the location of the service disconnect. The NEC requires the service disconnect to be readily accessible. This means that it must be located in a place where it can be easily reached in case of an emergency. The service disconnect must also be clearly marked to indicate its purpose. This helps to ensure that anyone who needs to disconnect the power to the building can do so quickly and safely. The height of the service disconnect is also regulated by the NEC. The NEC typically requires the service disconnect to be installed at a height of not more than 6 feet 7 inches above the floor or working platform. This ensures that it can be easily reached by most people. In some cases, it may be necessary to install multiple service disconnects. This might be required if the building has multiple tenants or if the electrical load is too large for a single disconnect. The NEC contains specific requirements for the installation of multiple service disconnects. These requirements cover topics such as the number of disconnects permitted, the location of the disconnects, and the coordination of the disconnects. The NEC also addresses the issue of service equipment bonding. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault currents to return to the source. This helps to prevent electrical shock and minimize the risk of fire. The NEC requires all service equipment, including the service disconnect, the meter enclosure, and the grounding electrode system, to be properly bonded together. The bonding connection must be made using approved methods such as bonding jumpers or bonding bushings. It's also important to ensure that the bonding connection is properly sized to carry the maximum fault current that could occur on the system. In addition to the general requirements for service entrance cable and service equipment, the NEC also contains specific requirements for certain types of occupancies. For example, the NEC has specific requirements for service entrances in healthcare facilities, schools, and hazardous locations. These requirements are designed to address the unique electrical safety challenges presented by these types of occupancies. Healthcare facilities, for example, require special grounding and bonding systems to minimize the risk of electrical shock to patients. Schools require additional overcurrent protection and ground fault protection to protect students and staff from electrical hazards. Hazardous locations, such as gasoline stations and chemical plants, require explosion-proof electrical equipment to prevent ignition of flammable gases or vapors. When working on electrical systems, it's important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that could occur when a high-voltage arc forms between two conductors. Arc flash can cause severe burns, blindness, and even death. The NEC requires employers to provide employees with appropriate personal protective equipment, PPE, to protect them from arc flash hazards. This PPE might include arc-rated clothing, face shields, and gloves. The NEC also requires employers to conduct arc flash hazard assessments to identify potential arc flash hazards and implement appropriate safety measures. These safety measures might include energizing equipment before working on it, using insulated tools, and maintaining safe working distances. The NEC is a complex and comprehensive document. It's important to consult the NEC and local codes whenever working on electrical systems to ensure a safe and compliant installation. If you're not familiar with the NEC, it's best to hire a qualified electrician to perform the work. A qualified electrician will have the knowledge and experience necessary to ensure that the electrical system is installed correctly and safely. In summary, the 10-foot rule for service entrance cable is a critical safety requirement in the NEC. It's designed to limit the length of unprotected cable inside a building and provide a convenient point to disconnect the building from the power source in case of an emergency. However, it's important to remember that local jurisdictions may have more stringent requirements, so it's always best to check with the local code authority before beginning any electrical work. And if in doubt, consult with a qualified electrician. The NEC Section 230 covers services. It delineates requirements for overhead service conductors, underground service conductors, service entrance cables, raceways, and equipment. Section 230.6 specifically addresses conductors considered outside the building. According to 230.6, conductors are considered outside the building under any of the following conditions. Firstly, were installed under not less than 2 inches of concrete beneath a building or other structure. Secondly, were installed within a building or other structure in a raceway that is encased in not less than 2 inches of concrete or brick. Thirdly, were installed in a vault that meets the construction requirements of Article 450, Part Roman 3. And fourthly, were installed in rigid metal conduit or intermediate metal conduit under not less than 18 inches of earth. This exception regarding the 10-foot rule is found within 230.6, which generally defines what is considered outside the building. The exception allows a limited length of service entrance cable to extend inside the building before reaching the service disconnecting means. This recognizes practical installation considerations while maintaining a reasonable level of safety.